I'm going to show you how to do more advanced power problems here. Um, the key here is that this thing that we call work doesn't have to be just work. It's really any change in energy. We've already solved one where this work was ended up being the MGH, right? The change in potential energy. It could also be a change in kinetic energy. It could be, and we'll do an example of this, it could be any combination, right? It could be any total change. It could be the kinetic and potential, the difference in the kinetic and potential and the kinetic and potential. And then this is just the time it takes. Okay? So here's an example, right? Car is speeding up from 12 meters per second to 25 meters per second, and it does it in 4.6 seconds on the level. What's the power? Well, for this, the work is going to be the change in kinetic energy, right? And so let's figure that out first. Change in kinetic energy will be 1/2, and you figured out how to do this, right? 2340 times 25 squared, right? That's the final kinetic energy minus the initial 1/2. 2340 times 12 squared, right? Okay, so 0.5 times 2340 times 25 squared minus 0.5 times 2340 times 12 squared. This change in kinetic energy is 562,770 joules of change. Okay, let me double check, make sure I did that. Indeed I did. Okay, so this becomes my work, right? That is my work, and then to figure out the power, I just go work divided by time, and that equals, 562,770 joules divided by 4.6 seconds, right? Right, so I'm going to take the number that's on my calculator, divide by 4.6, and I get a lot of watts. Equals 122,341 watts. And we're done here. Now, just, I'm curious about this, right? That's watts. That's 122 kilowatts. So the question is, how many horsepower is it, right? I'm going to divide that by 745.7, and I get 164 horsepower, which seems like a reasonable amount of power, right? That's not something you always do, but there we go. We're done with this number. So let's look at another example problem. It takes a 780 kilogram, it's supposed to be an elevator car, right? And it speeds it up from rest to 5.4 meters per second in 4.1 meters, and it does that in 1.51 seconds. Holy cow, look at that thing, right? And so in this case, I'm going to say, the elevator is, down here, it's not moving, so I'm going to say it doesn't have any energy, and then, when it's vertically upward 4.1 meters, right? It's also moving, and so I'm going to say that the total work done here is the kinetic and the potential it has at the top here, right? So work in this case is the 1/2 mv squared it's got, and the potential, right? Okay, so I can do that. Let's see, 1/2 times 780 times 5.4 squared plus 780 times 9.81 times, let's see, 4.1 meters. Okay, that's my work, so I can figure that out. Let's see, 0.5 times 780 times 5.4 squared plus 780 times 9.81 times 4.1, and I get 42,744. 0.78. Okay, and let's see. So power is work divided by time, right? And this is my work, right? The work is the change in kinetic and potential energy, right? So that's 42,744.78 divided by how long did it take? 1.51 seconds, right? Okay, so I'm going to divide this by 1.51, and I get 28,307.8. Now we only have 2 sig figs, so I guess we'd have to say 28 kilowatts. Yeah, 28,000 watts, right? That's what a kilowatt is, huh?